Today we are going to use something called the zero product property. At the end of our last unit, we talked about intercept form, and we didn't really need it for the test, but I told you that it was like critically important for algebra. And today we're going to start to see why. So if you remember, or even if you don't, I'll remind you, this is what intercept form of a quadratic looks like. If you look at the x's, when I do x times x, I get x squared. So it's definitely quadratic. You just can't see the power of 2. You know what I mean? Okay. So it has our regular a value, the same a value that we have in vertex and standard form. The a will either open our parabola up if it's positive or down if it's negative. It does our vertical stretching, which makes the parabola narrow, or it vertically compresses, which makes our parabola wide. Okay, we don't have A, B, and C, or H and K, we have P and Q. P and Q are called our solutions or roots. Okay, there's one other name that your calculator uses. Zeros, yes. Good. Okay, P and Q make the equation true when we set the y equal to 0. Okay, we're going to list roots in curly brackets. Now, looking at this graph over here, we can use it to find our a value. So we can use our pattern. If I look at my vertex and I go right 1, what does my graph do? Down. How many? 1. And then start at the vertex again. Now go right 2. What does the graph do? Yeah, down 4. So if instead of going up 1 and up 4, it goes down 1 and down 4, what do I know the a value has to be?
1.
What kind of 1? Negative 1. Okay, now, what are our zeros according to this picture? -5 and -1. The zeros, or the solutions, the roots, are the x values where the graph hits the axis. So this is the point -5, 0, and this is the point -1, 0. So these are the x-intercepts. These are the roots. They're cousins. They're obviously related. They tell us the same information, but they're different. This is a set of points. This is a set of values. Cool? Okay. So now we can write our equation in intercept form. We're going to use that one right there. Y equals, what's our a value? -1, open parentheses, x minus a -5. When we do minus a negative, it turns into a positive. And then we do x minus a -1, which also turns into a positive. Okie dokie. Next. All right, so we want to write quadratic functions. Does anybody remember from Unit 3, when we had to write it a million times, what the definition of a function is? It is starts with an R, relation where each what? Yes, input has, you got it right, exactly Oh, that's an alternate spelling. Exactly one output. Good. Okay, the other day, kids were asking me, what's a function? I'm like, oh, we need to review this. All right. So just like up there, we're going to write an equation in intercept form to represent our graph. So we need three things. We need A, we need a P, and we need a Q. Which one do you want to get first? A. All right, so start at the vertex and find the pattern. If I go right 1, how many do I go up?
2.
Well, we're going up 2, so it's a little bit stretched. How much do we stretch it by? Yeah, because the normal pattern just goes 1, 1, right? This one is twice that. All right, what's the P? Yeah, -1. What's the Q? What? I thought I heard it. Yeah, +1. Okay, now we have everything we need to write our equation in intercept form. So it will be y equals our 2 times x minus -1, which turns to plus, times x minus 1. Cool. Okie dokie. All right, let's convert it to standard form. So first we start distributing our 2 into the parentheses. So it'll be y equals 2x plus 2 in the parentheses. And then bring down your x minus 1. Okay. Now we have to distribute again. 2x times x gives us 2x squared. 2x times -1 gives us -2x. 2 times x, +2x. 2 times -1 gives us -2. What do you notice about our like terms? Yeah, they have the same magnitude, but they're opposite in sign, so bye. So my final standard form answer is y equals 2x squared minus 2. Okay, we're going to come back and do some stuff in the other boxes, but for right now, we're going to flip. Flip. Watch me, Nene. All right, we know that yesterday we did the square root method. Today, I promised you that we were going to learn about the zero product property. The zero product property is the thing that makes factoring work. Okay, we don't know how to factor yet, but we're going to start learning that tomorrow. So, what do we know that we already need to make the y value equal to? Not 2. 0. Okay, so we have to make the y 0 because that's where our x-intercepts are. The y's are 0 and the x-intercepts. Okay, so if our y value is 0, then either our x minus p part or the x minus q part has to be 0 if our equation is going to be true. Okay, that's a lot of words. Let's think about what that means. Let's say that I have a product that's 0. Okay, and pick a number.
5.
Okay, and I'm going to say n. And I'm multiplying the 5 and the n together. Okay, so these are my factors. This is my product. If my product is 0, what does n have to equal? 0. Because the 5 isn't going to get me to 0 by itself. 5 is 5.
Do you have Andrea Hardy in class?
Yes.
Can you please send her to...
So, this is really important and we kind of lost you. All right, come back. If our product is 0, then at least one of our factors has to equal 0. Everybody happy with that? Yeah. Okay, so same thing here. If we have a product of 0, then either this factor or that factor has to equal 0. That's the ZPP. All right, so our steps when we solve are number 1, make the y 0. Set y equal to 0. Step 2, set the factors equal to 0. So we have 3 factors. First factor is the -1, that's the a value. Second factor is the x minus 4. Third factor is the x plus 2. Everybody see the 3 things that are being multiplied? Okay. So we've got a -1 that we have to set equal to 0, an x minus 4 equal to 0, and an x plus 2 equal to 0. So these are 3 different little baby equations. And we have to solve all of them, but they take like a second. Okay, does -1 ever equal 0? No. So this one is actually a garbage one. It doesn't give us any solutions. It's garbage. Yeah. All right, what about this one? What take away 4 is 0? Yeah. All right, next one. What plus 2 is 0? -2. Do you guys see a pattern that it just had to be the opposite? Like if I've got a -4, it had to be positive. If I've got a +2, it had to be negative. Okay, so step 2 was set factors equal to 0 and solve. Okay, now I've got some x values that should make my y 0. It's time to write them in curly brackets. So step 3 is to put my p and my q in some curly brackets. What order do they go in? Most negative to most positive. So we start with the -2 and then we go do the 4. Okay, just to give us an idea of what it is that we found, we're going to draw a little sketch. Ooh, gross. Oh, worse. Okay, that was better. So it was -2 and +4, right? That's where I'm hitting the x-axis. So my x-intercepts should be -2, 0. Here, I'll put them over here. Sorry. -2, 0, and 4, 0. Everybody understanding what's happening? Now we can check our work really easily by plugging them in and testing them. So that's what we're going to do right now. This is our check. Okay, so we just take each of these x's and plug them in. So 0 equals negative, open parentheses, x minus 2. Oops, sorry, I forgot to plug in the 2 for the x. We're plugging in the negative 2 right here. Negative 2 minus 4 is what I meant to say. Open parentheses, negative 2 plus 2. Do you see how both times I used the negative 2? Okay. So negative 2 minus 4, what's that? Negative 6. And negative 2 plus 2? 0. Why is that important? Because no matter what this is over here, we don't care about these clowns. Anything we multiply by 0 is going to give us 0 and make the equation true. So this one works. It's true. Cool? Let's do the other one. Okay, 0 equals the opposite of 4 minus 4. Now I'm plugging in 4. Times 4 plus 2. Okay, the 4 plus 2 is giving us positive 6. What's 4 minus 4? 0. 0 times the rest of this stuff gives us 0. So it works. Those are the x values that make our y 0. Happy brains? Okay, cool. All right, let's do Let's do example 3. All right, so we make our y 0. Now we get to go fast. We've got 2 factors, 1 and 2. We set each of the factors to 0. 2x equals 0. X plus 5 equals 0. These are 2 separate equations that we solve. We put our phones away. Okay, divide both sides by 2. And we get x equals 0. Okay, subtract 5 from both sides. And we get x equals negative 5. Okay, we write our solutions in curly brackets in ascending order. And we're done. Okay, I need your help with something. For number 4, I want you to cross it out. And I want you to write something else instead. Oh, you thought you were going to not have to do one. Which one do I want to do? Okay, I want to do this one. Y equals x plus 5 squared minus 81. My ear itches, sorry. All right, now we're going to flip to the front. We're going to jump around. I really kind of had a brain fart when I was doing these notes, but we're going to make it work. Okay, so today we learned about the ZPP. Look at this one right here. Do you see that we have our beautiful factors all multiplied together? We have all factors. Okay, if we have all factors, we can use the ZPP. Zero product property. So I can make my y 0 and set each of my factors equal to 0. X plus 1, x minus 1. We're going to do this fast. So it'll be x plus 1 equals 0. X minus 1 equals 0. Solve each of these for x. Subtract away 1 from both sides, I get x equals negative 1. Add 1 to both sides, I get x is positive 1. Put my solutions in my curly brackets. Negative 1, positive 1. Okay. Look at my picture. Where do we hit the x-axis? Negative 1 and positive 1. Look at my P and my Q. What are they? It's all connected. Do you see how cool this is? Okay, yesterday we did something else. Let's say that I don't have factors. Look at this down here. Do I have factors here that are multiplied together? If I don't have factors, there's no ZPP for me. I can't use the ZPP. But if I set my y equal to 0, could I get the squared part alone? Yeah. So here I'm going to use the square root property. Okay, so I'm going to take the square root. I'm going to make my y 0. I'm going to say that is equal to 2x squared minus 2. I'm going to add my 2 to both sides. Get 2 equals 2x squared. Divide both sides by 2. I get 1 equals x squared. How do we undo squaring? I'm going fast. I'm sorry. How do we undo squaring? Square root. Square root. Square root. Don't forget the plus minus. What is the square root of 1? 1. So I get positive and negative 1 equals x. Write them in curly brackets. I get the same P and Q. That's pretty cool. Like if I had a mic right now, I'd be dropping it. All right, let's flip to the back. All right, we are not going to do example 6, but I want you to look at number 4 and number 5. Which method should we use for example 4? Yeah, this one is a square root method one. We would use the square root property. Does everybody see why? So this one, I want you to write square, root. All right, what about this one? Number 5. Square root or ZPP?
ZPP.
Yeah. If we have beautiful factors, then we get to use the ZPP. Because it's the factors that give us a product. All right, we're going to do this one. So we set the y equal to 0. We set each factor to 0. 4 equals 0. That's a garbage one. 5x minus 2 equals 0. 5x plus 2 equals 0. Okay. How do we undo subtracting 2? Add 2. So I get 5x equals 2. How do we undo multiplying by 5? Divide by 5. So I get x equals 2 fifths. All right, what about this one? How do we undo adding 2? Subtract it. So I get 5x equals negative 2. All right, look at this one. What did we have to do with the 5? Yeah, we have to divide it again. So this one gives us x equals negative 2 fifths. Does it surprise anybody that they're just opposites of each other? If you're looking at these signs? Okay, so just put them in curly brackets and we're done. I'll let you do your homework. Negative 2 fifths and positive 2 fifths. All right, go, go, go.